Okay, next let's move to quantum theory. Quantum theory is a theory or a knowledge about a small thing. What is small thing? Small thing, we talk about the small thing here. We talk about subatomic particle. What is subatomic particle? This is where the particle that containing the electron and proton. So when we have a look at the human development, we see we are able to achieve a good knowledge before, where we are able to devise a good theory for a large object like a galaxy, astronomy, like a lot Earth, like a large particle where we can predict the movement by using a certain equation, a certain theory, such as, if you still remember, that we are using a Newtonian theory, like law of thermodynamics. This is something that the theory about a macroscopic object. However, when we have a microscope, everything start to change, because by using this, we are unable to use the theory that explains the large object. We are able to use that anymore, because when we have a small particle like atom, carbon nanotube, transistor, everything is different. So we are unable to use the same theory as we use to explain the properties of a large or macroscopic material. Yeah, the theory is good to explain the macroscopic material. However, when it comes to small atom, it can't fit, or it can't explain the behavior anymore. So that's why we have a quantum theory. So for example, I can give you this example. So for instance, we have an electron and we have electric field. So electron is a negative charge. Electric fields have charges. So what will happen by if we are using classical theory, this electron will be repelled, because both have negative charges. So negative will always repel. So that's why I said that in classical physics, the electron is repelled by an electric field, as long as the energy of electron is below energy level of this field. So if this electron wants to surpass or this field, this energy of the electron must be higher than this electric field. So this electron can pass through this electric field. However, later on in the quantum picture, what happens is, when we have an electron here, this electron can pass through this electric field. So what happened in quantum physics? So it stated that the wave function of the electron encounters the electric field, but has some finite probability of turning through. So this electron wave, can pass through. So in quantum physics, it stated that this electron is always repelled. However, on the other side of the barrier, it does not have enough energy. If stated that this electron can pass through of this wall. So stated that if the world is much thicker than the quantum wavelength, tunneling becomes improbable. So this is the basis of the transistor that we have now. And then, using this word theory, or this quantum theory, we are able to design and build a lot of electronic devices as semiconductor, computer, cell phone, also laser based products such as CD, DVD player. We have a Blu-ray, barcode scanner, surgical application. We have a MRI that is a leapfrog in medical application. Where MRI is magnetic resonance imaging technology, where we can save a lot of, can save thousands of people. We can diagnose the disease of people. We have a nuclear reactor where this nuclear reactor give a lot of energy and benefit many kind of people around the world. We also have atomic clocks. Atomic clock is something that is very been used to determine, or to, if I don't forget, is to determine the time accurately. We have a GPS navigation, kind of that, all of these things. Because this weird theory, even though it is difficult to understand, however, this theory is fit very well with this electron, and from there we can understand this atomic particle well, and later on we can get a lot of application of the how to apply the nuclear, how to apply the light, how to apply the resonance of the wavelength, and some kind of all that. This theory is very well, and from there we are able to develop high tech product where it's used derived from the quantum theory. So when we talk about quantum theory or quantum mechanics, we also need to understand what is classical mechanics, because this quantum mechanics is the quantum mechanics is the foundation of the motion that we have in this world. So the physical theory describes the motion of microscopic object from projectile to parts of machinery, and astronomical object can be predicted. So that's why, by using a certain theory or mathematical expression, we can predict the movement of object. For example, I believe that you understand about the kinetic energy. So we have, if I know mistaken, kinetic energy is mv squared. So by using this, we can predict the energy of something, of a movement object. So that's why we take that it's possible for us to predict how the microscopic move, and we can predict it either the future or the past, and then the earliest development of classical mechanics is always referred to Newtonian mechanics, where from the Newtonian theory or Newton theory, we can derive a lot of theory later, because the theory is become the foundation of the classical mechanics. And the theory is a theory that is describing the motion of microscopic objects. So by using this classical mechanics, for example, we can predict, or we can predict the movement of like, for example, like moon here or satellite here. We can predict it, how the degree, you just name it, the degree, the motion of it, anything regarding the motion of this object. So what is the Newtonian mechanics? It consists of the physical concept based on foundation work that have been proposed by Sir Isaac Newton. And then later on from this work, there is a mathematician and a physicist that are try to elaborate more. So that's why we have a lot of mathematical theory that is invented by Gottfried, like Wilhelm Leibniz, Joseph Love language. So we have a lot of their name in Newtonian or in classical mechanics. Later on, more abstract method were developed, leading to the reformulation of physical mechanics known as Langerian mechanics and Hamiltonian mechanics. Langerian mechanics and Hamiltonian mechanics also became a foundation to quantum theory. So by using a few modification of Langerian and Hamiltonian mechanics or theory, later on this theory become a substantial theory to develop the quantum mechanics. So when we go to the quantum mechanics, we need to admit that this classical mechanics provide extremely accurate results when studying microscopic object, where the object have a certain speed that is not approaching the speed of light. However, this classical mechanics have its own limitation. So this mechanics have its own limitation, where when it fails, when we want to use this theory, we want to apply it to small object, like very extremely small object, like a size of atomic diameter. So that's why it's necessary for us to introduce quantum mechanics. So this quantum mechanics are able to describe velocity that are not small compared to the speed of light. Special relativity is needed here. F sector is needed here. However, a number of modern sources do include the statistical mechanics in classical physics, which in their view represent classical mechanics in its most developed and accurate form. So from there, scientists will try to develop or reformulate the classical mechanics. However, this classical mechanics is not good enough to describe microscopic behavior. So still we need to introduce the quantum mechanics. So for the quantum mechanics view, quantum theory stated that all small particles has particle wave properties or duality. So it exhibits particle properties and also wave properties, where if we go to macroscopic object, it is either one, either the matter can produce a particle properties or wave properties, but not for quantum theory. So particle waves are described in a probabilistic manner. So it's stated that this electron does not whiz around the nucleus. It has a probability distribution describing where it might be found. So for example, if we remember, we did this experiment, I think that young double slit experiment, to determine the properties of electron.